Hello students, I am Dr. Tanmoy Vishwas. I welcome you all in my channel Chemistry, the Mystery of Molecules. So in today's lecture, we are going to discuss a multiple choice question about radioactive scrambling pattern through a particular reaction. For that purpose, you can see the question in front of you. This is the question. So this star mark means this carbon contains a radioactive element, means that is carbon 14 radioisotope. In presence of HBr and AlCl3, if you carry out reaction, sometimes there is a slight heating, what will be the major product? So this is the question. For that purpose, 4 options are provided in front of you. So you have to find out what is the right answer. As usual, I first request you, please pause the lecture and try by yourself. It will help you for self-evaluation, and I suggest you please write your answer on the comment box. Okay, don't worry whether this is right or wrong, doesn't matter, just write. And definitely after some time I shall explain the whole phenomena with complete explanation and mechanism. So today's lecture will cover few points like the basic property, reaction mechanism, and source of some radioisotope. Okay, so this lecture is going to be very interesting because this is little different than traditional chemical reactions. So I request you, please watch with complete attention. Okay, let's start. Okay, so as usual, I first explain what is the nature of the reagent. Why? Because I believe if you understand the nature of the reagents properly, then you will be able to understand, you will be able to predict that proper answer. Okay, fine. So in this case, what are provided? This toluene 1, this is AlBr3 and HBr3 are our reagent. So first look at this AlBr3 and HBr. Finally after that we will come to toluene. This AlBr3 is a Lewis acid. Why? Because the outermost valence shell of the aluminium 3 plus a sextet or 6 electron. Okay, so this means it is electron deficient, because in order to fulfill its electron deficiency it need to have 8 electron in the outermost valence cell. Okay, fine. So this is the property. And HBr, this molecule can act as a acid means it can produce the H plus and Br minus, and since all are in the reaction medium, so what can happen? These Br minus can attack to this, means bind to this aluminium 3 plus, and what it will result? It will result in AlBr4 minus anion, and right now this is 8 electron species, so octet is fulfilled. So in conclusion, what it will produce? It will produce this H plus AlBr minus. And see, H plus is a strong acid, and when the counter anion is stabilized by something else, then its acidity or strength increases further. Okay, so it is far more stronger acid, and what it can do? It can participate in aromatic electrophilic substitution. How? I'll explain. So if I look at this molecule is nothing but actually an electron rich arene. Why? Because this toluene is attached. It is ortho and para orienting and activating, and I have already uploaded a dedicated lecture about the nature of substitution on aromatic nucleus and whether they are orthopara active or orthopara directing, meta directing, or whether activating, deactivating. I suggest you, if you haven't read that lecture, please read. This is very important from the basic understanding point of view. Okay, so it is a electron rich alkene and attached to it means methyl group, so it can undergo this Friedel-Crafts alkylation reaction, and you need to be convinced that not only alkylation, dealkylation is also possible in presence of Lewis acid. By the way, I have already uploaded a dedicated lecture about Friedel-Crafts alkylation and dealkylation. I know this dealkylation part seems to be little complicated or unknown to you, so please read that lecture. If you think that you have no idea about this, pause this video right now, finish that video and come. I shall give the link in the I button. Fine. So what happens? Actually, in this case, what happens? Scrambling occurs. I'll explain details. And what do I mean by scrambling? Scrambling means distribution of the radio label. In this case, carbon 14, because this carbon is 14 and radio label, I'll explain why. How? Through some part of the molecule, through some chemical transformation, and this chemical transformation is Fc alkylation and dealkylation. Okay, so this is the chemical reaction. Now scrambling means, for example, in one molecule this is here, in another molecule this is here, in another molecule this is here, another molecule this is here, and it's symmetrical, so left side will be same. So we can consider the radio label is distributed all over the ring carbon. But don't be confused, this methyl carbon, it never undergo, it will never have the scrambling. Only the benzene nucleus carbon atoms will have the scrambling, means distribution of the radiocarbon. Okay, means it's a average thing. Okay, you'll understand after some time in details. So let's look at the mechanism of the Friedel-Crafts alkylation and dealkylation. What's actually happening in this case? See, this AlBr3, as I told, it will coordinate to this Br minus and produce this H plus, and these H plus will react with toluene and be attached to this benzene nucleus carrying the scrambling, means this one, and this is called actually ipso substitution. I have already uploaded a lecture about this ipso substitution, you can visit. Fine. So this is, now what can happen? See, in this case aromaticity is means gone, this is aromaticity is lost, and we know aromaticity is a very stabilizing energy. So molecule will try to gain back the aromaticity, and for that purpose what it can do, it can either eliminate or leave the proton, this proton can leave, or the methyl cation can leave. If the proton leaves, then it will result in the primary thing, means the previous one, means this one. And if the carbocation leaves and methyl cation, then it will produce this one. Now you may say that, sir, is methyl a very good leaving, means is methyl cation is relatively stable? Exactly saying it's not. But when you are doing a particular reaction under a particular environment, in that environment it is possible to generate. Okay, so fine. So in this case we have generated this methyl cation, and see this AlBl4 minus. You can consider this thing as a product of methyl bromide plus AlBr3. If you think in this way, I believe you will feel little easy to understand the story. The chemistry will be easier to understand. Means if you react this CH3Br and AlBr3, it will result CH3 cation or AlBr4 minus anion, and this can undergo, again we know that, sorry, this can undergo Friedel-Crafts alkylation. Okay, so the first step, so that this step is dealkylation, this step is FC dealkylation, and after, so in next step what can happen? It is possible that methyl cation can participate in Friedel-Crafts alkylation. So where it can happen, logically all these six, means what I mean 1 2 3 4 5 6, and substitution having equal probability for substitution on every ring carbon. Okay, so if the probability is equal, so what can we get? We can get the reactant, means this one. Okay, the reactant, we can get, this is this para type. I should not say para, because isotope changes only the physical property, the mass. Chemical property are almost intact. So this, so in this case, with respect to, if we consider, this is the para, this is the ortho type, this is the meta type, substitution and reactant. So if you take a average, means if you superimpose 1 2 3 and 4 reactant, and if you look at, what will you observe? you will observe that radiocarbon is distributed over all ring carbon. Okay, that is, and that's why this is called scrambling, means the distribution of the carbon all over the ring carbon. Okay, I am telling again, the methyl group will never have the label, so no label on the methyl group. Fine. So this is, so you have understood. And what is ipso substitution? Ipso substitution is nothing but aromatic electrophilic substitution at the position where the functional group is attached. This is, you will understand this ipso substitution in the link of the dedicated video. Okay, so we have understood the scrambling will occur all over the molecule. So consequently, what will be our product, our answer? Our answer is this one. Okay, so this is, now we have actually discussed with radioisotope carbon, better to say carbon 14 isotope. By the way, remember that carbon has three isotopes. One is carbon 12, another is carbon 13, and another is carbon 14. Almost 99% are this carbon 12. Okay, almost around 1% is carbon 13, and where this carbon 13 is utilized? 13C NMR spectroscopy. Okay, so this nucleus is responsible for 13C NMR spectroscopy, and carbon 14 very, very low, and actually this is a radioisotope. Okay, so let's discuss little bit about this radioisotope, how it's prepared and how it breaks down. Since radioisotope, so question, how this is produced? It is produced from nitrogen 14, is the most stable of most abundant of nitrogen atom, and it reacts with a neutron. So this is actually neutron. So in presence of cosmic ray means the ray comes from the sun, and it's a very energetic, very high energy radiation. So in presence of cosmic ray, neutron, this cosmic ray produces neutron, and it reacts with this nitrogen 14, means it's collide with the nucleus. Okay, so when it collides with the nucleus, what it does? It eliminates one proton. Okay, means proton means the reduction of atomic number. Reduction of atomic number. So if the reduction of atomic number occurs, then from lower atomic, below nitrogen, the atom is carbon, so it resulted carbon 14. See, neutron has a mass 1 unit, proton has a mass 1 unit. So this neutron will not change the mass of the nucleus, so that's why the mass of this carbon 14 nucleus is 14. So this carbon nucleus is, mass of this carbon nucleus is 14, and this is because of this higher neutron number. Actually it's not stable and it's breakdown, that's why this is called radioisotope. Okay, and question is, since it's a radioisotope, means it's not very stable, but I will not say it is not very unstable also. It has a significant half-life. Significant half-life is around 5730 plus minus 40. It's a significantly higher. Okay, so it is unstable, but this, and how it degrades? It degrades by production of again nitrogen 14 along with a electron and neutrino. Okay, we will not focus on electron. So these electrons sometimes considered as beta particle. So this is represented as this beta, so you can consider it's a beta particle. Okay, and using Geiger-Müller counter you can detect such kind of emissions. Now question, what is the use of this? Actually this is a natural phenomena to prepare radioisotope. Okay, so this thing is very useful for radiometric dating of carbon material containing carbon atoms, and we can check or prove its age up to 60,000 years. So just think how much useful this is to check any material, carbonaceous material related to human evolution. By the way, radiocarbon dating is not the only way to determine age. There are some other technique, for example uranium clock in this way. So those are not the discussion topic for today, but remember, not only radioactive carbon, some other radioactive element can also provide us the age of some material. Okay, so we have learned in this case that how this radiocarbon is produced, and second, how this degrades and what is its use. Okay, and these pulses could be determined using Geiger-Müller counter or GMC instrument. Okay, fine. So in conclusion, what you have learned today? In conclusion, we have learned today, first, Friedel-Crafts alkylation and dealkylation is a reversible reaction. That's why the methyl group comes out again at, means detached and attached will result, which resulted that scrambling, means distribution of the radiocarbon on every position of that benzene nucleus. Fine. Okay, another thing, in presence of HX, protic acid, which helps in reverse reaction of Friedel-Crafts alkylation through ipso substitution. Okay, because when it attaches to that carbon, means here when it attach, then only it possible to remove this functional group. Fine. Okay, scrambling of radioisotope may occur through a chemically symmetrical, better to say chemically symmetrical intermediate. Okay, here benzene, what do I mean? See, from this radioactive nucleus, means initially radioactivity is here, after that what it was produced? It was produced this plus this methyl cation. This benzene molecule is actually chemically symmetrical because this radio substitution is a nuclear phenomena which do not related to chemical properties. So this is a chemically symmetrical, and if it is chemically symmetrical, then substitution of this position, this position, this position, this, every position is equally probable. That's why it's a complete, almost complete distribution of the scrambling. Okay, fine. And the most important point of the discussion is that isotopic leveling is a very good technique to investigate the chemical mechanism pathway as well as age of old material. Why chemical mechanism? For example, you look at the reaction which we have discussed today. It means that Friedel-Crafts reaction and Friedel-Crafts alkylation, we know it happens by NMR, but is dealkylation possible during the reaction? So this is a proof that okay, dealkylation is also possible in the reaction. So this statement proves that this FC alkylation is reversible. Okay, so this is the achievement of this study. Okay, so this is the end of this discussion. I hope this lecture may be useful for you. If it is, then please please press the like button and write your opinion in the comment box, such that I am able to know what's your opinion, and always write your answer in the comment box, and share this video with your friends if you think it's worthy. And most importantly, if you think my channel is a deserving channel, then please subscribe and press the bell icon such that